In this video, we're going to be doing a Unit 4 linear momentum MCQ. So a force on a 2.0 kilogram object varies with time f of t is equal to 4t for 0 is less than or equal to t is less than or equal to 3s. The object starts from rest. What is its final velocity? So impulse is equal to the change in momentum, and also impulse is equal to the area under the force graph. So we can represent this, since we have that f of t is equal to 4t, we can just write our impulse with the limits of integrations 3 and 0, 4t dt. So now we just evaluate the impulse, so we're just going to factor out that 4, and this is equal to 4, 3, 0, t dt. This is equal to 4 t squared over 2, 3, 0, and this is equal to 9 over 2, and this is equal to 18 newtons times seconds. So your answer is, for delta P, is 18 kilograms. So this is 18 kilograms times meters per second. But for this question, we want to know what the final velocity is. So if we know that P initial is equal to 0, then we know, and we also know PF is equal to 18. So since we know that P is equal to M times V, 18 is equal to 2.0 times V. So V is equal to 9 meters per second. So your answer is 9 meters per second. Now for our next question, a 6-meter object at rest explodes into 2 pieces. One of mass 2m and another of mass 4m. The 2m piece moves to the right with a speed of 3v. What is the velocity of the 4m piece? So if they explode, they're going to explode in opposite directions. The 2m piece is going to have a velocity equal to 3v, and the 4m piece this is 2m, has a velocity equal to something that we don't know. So if we know in this scenario that we don't have any external forces acting, we have conservation of momentum. So P initial is equal to PF, but P initial, since we know that it starts at rest, P initial is going to be equal to 0. And we also know that the final momentum is also equal to 0 then, because they're equal to each other. So now we can write our moments of inertia. So for the 2m piece, we're going to have 2m times 3v is equal to 6mv. Now for P2, we have 4m times u. U is equal to the velocity. Now you can set your total momentum equal to 0. So you have 6mv plus 4mu is equal to 0. You have 4mu is equal to negative 6mv. U is equal to negative 6mv over 4mv. U is equal to negative 3 over 2v. So your answer is going to be A. You have a 1.0 kilogram block moving at 10 meters per second, and it slides across a rough surface with a coefficient of friction equal to 0.2, and it stops. So what is the impulse that you receive from the friction from the block? How do we calculate this? We use the impulse momentum theorem. So impulse is equal to the change in momentum, which is PF minus P initial. So our initial momentum is equal to mass times velocity, which is going to be a mass of 1.0 times a velocity of 10. So that will give you 10 kilograms times meters per second. You multiply the units of each of those respective values. And since we know that the ball is going to stop, it comes to a rest, that means that PF is equal to 1.0 times 0 is equal to 0. So then your impulse is equal to the change. So that's going to be 0 minus 10. Your answer is going to be negative 10 newtons times seconds. So all you had to do was calculate that momentum and infer what the other momentum was and then find the change. So that's how you found the impulse. And what the negative sign here means is that the friction opposed the block's motion. So two carts on a frictionless track, M1 is equal to M, and it has initial velocity of 4m, and M2 is equal to M is going to be at rest. So after a perfectly elastic collision, what is the final velocity of M1? So when you have elastic collisions, when you have a perfectly elastic collision between two masses that are equal to each other, they are going to exchange velocities. So what happens is if one mass is moving, and the other mass is initially at rest, the first mass stops, and the second mass moves off with the original speed. Therefore, we already know that V1F is equal to 0. So how do we get this, though? We can get this by writing out our conservation of momentum equation for both sides. So we have the mass, and we know that velocity of the first object is going to be 4. So we can fill that in. And we also know that the second mass, M2, has an initial velocity of 0 because it's at rest. And we can set that equal to mv1f plus m2v2, or yes, m2v2f. Label this m1 as well, m2. So now all you have to do is see that on both sides here we have m. You can just cancel that m out to make everything more simpler. So you have you have 4 v1f plus v2f. Now you can use your conservation of kinetic energy. So you have 1/2 m4 squared plus 1/2 m0 squared is equal to 1/2 mv1 squared f plus 1/2 mv2 squared f. So you can cancel out that 1/2 m from all of these, 1/2 m, 1/2 m, 1/2 m, and you're left with 16 is equal to v1f squared plus v2f squared. Now you can solve the system. So from equation 1, we have the v2f is equal to 4 minus 1 over v1f, which we can rewrite here. For v2f is equal to 4 minus v1f, and we're going to call this equation 1. So now this is our equation 2. Well, we can write it up here as well. So this is v2f is equal to 4 minus v1f. That's 1. So we're gonna let's do this here, sub 1 into 2. So you will have 16 is equal to v1f squared plus 4 minus v1f squared. This is 16 is equal to v1f squared plus 16 minus 8 v1f plus v1f squared. 16 is equal to 2 v1f squared minus 8 v1f plus 16. 0 is equal to 2 v1f minus 8 v1f. 0 is equal to 2 v1f. v1f minus 4. So that means that in this case you have that you can use a zero product property. So 2v1f is equal to 0, and you also have v1f is minus 4 is equal to 0 plus 4 plus 4. 4 is equal to v1f, or divide by 2 here. v1f is equal to 0. Now, if it was 4, that means nothing would have happened. Which is not the collision result here. So that means that your physical answer has to be v1f is equal to 0. So your answer is going to be a 0. So let's say we have a 2 kilogram cart moving at 5 meters per second, and it experiences a constant external force of 4 newtons opposite its motion for 3 seconds. What is the cart's final momentum? So we have to find our initial momentum. Our initial momentum is equal to mass times velocity, which is going to be 2 times 5. That's going to be 10 kilograms times meters per second. And you have to find your impulse from your external force. So impulse is equal to the force times the change in time. So because we know that the force is going to be opposite its motion, that means that it is going to be a negative force. So if you have a negative force, we'll just plug that in here. Impulse is equal to negative 4 times 3, which is equal to negative 12 newtons times seconds. So if we use the impulse momentum theorem, you're going to have that impulse is equal to the change in momentum, which is PF minus P initial. So we already have that our impulse J is equal to negative 12 times Newton times seconds. So that's negative 12 is equal to PF minus 10. So this was your negative 12. And you get your minus 10 because we got our P initial over here. Negative 10 kilograms times meters per second. Now all you have to do is just solve for what PF is. So you just add 10 to both sides. You get that PF is equal to negative 2 kilograms times meters per second. So what that negative sign means in this context is that your cart actually reversed direction. So our options are only positive values, which means that if you take the magnitude, we're going to alter this question to say in magnitude. So the absolute value of this momentum is just equal to 2 kilograms times meters per second. So your answer would be A. Now let's do our next problem. A 2-meter object moving right at 3v collides and sticks to an object moving upward at 4v. What is the magnitude of the final velocity? And this is going to be equal to m. Your v2 is equal to 4v. So let's let our right-hand side be positive x and up be positive y. So that means that for object 1, we'll label this as object 1 and this is object 2. Your mass is 2m, your velocity is 3v to the right. So your p1 x is 2m times 3v, which is equal to 6mv, and your p1y is equal to 0. Now for your second mass, your p 2x is equal to 0. Your p to y is equal to your mass times your 4v, which is equal to 4mv. So now if you calculate your total momentum, you're going to take your pfx is equal to 6mv, and your pfy is equal to 4mv. Now, if they stick, that means that your total final mass is equal to 2m plus m, which is equal to 3m. Now, you have to find your final magnitude of your momentum. So that's the magnitude of your final momentum. You're going to take your pfx squared plus your pfy squared. So this is going to be the root of 6 mv squared plus 4 mv squared. Now what you can do here, you can take out that mv. You'd have mv root 36 plus 16. Then 36 plus 16 is equal to mv times the root of 52. You can take out a 2, so that's mv root of 13. Now, if we use how pf is equal to mv, we can write pf is equal to 3m for the 3m object times vf. 3m vf is equal to 2m v root 13. So vf is equal to 2 root 13 over 3v. So that's going to be your answer. The answer is not listed here, so all these are actually wrong. This was the right answer. Now, a force versus time graph is triangular with a base of 4 seconds and a height of 6 newtons. What is the impulse? So your impulse is going to be the area under your force time graph. So for impulse, that's equal to 1/2 the base times the height. That's equal to 1/2 of 4. Your time is going to be in seconds, and your height is going to be your force, which is in newtons. So that's going to be 4 times your 6, which is going to be 12 newtons. You just multiply that by the unit of seconds. So that's 12 newtons times seconds. Now, two identical masses collide head-on. In a perfectly elastic collision, the total kinetic energy is equal to K1. In a perfectly inelastic collision, the total kinetic energy is equal to K2. When you have elastic collisions, and also any type of collisions, your delta P is conserved. Your kinetic energy is conserved. Your system is going to keep as much kinetic energy as possible. Now, if you have a perfectly inelastic collision, your momentum is conserved. Your kinetic energy is not conserved. So that means that some of your kinetic energy is lost to heat, sound, deformation. So that means that your K1 is going to be less than your K2. So that's going to be option B. A bullet of mass m embeds in a block 4m. The system moves with a speed v after the collision. What was the bullet's initial speed? So we're going to use conservation of momentum because this is a perfectly inelastic collision. Because when the bullet gets stuck in the block, they become one object and they stick together. And in any type of collision, you always have the momentum conserved. So that means we can split this into before the collision. And we can also split this into after the collision. So before the collision, you had a mass of m, and your speed is equal to u. And then after and you're also, so this is for your bullet. So let's actually label that. So m of the bullet, m of v of the bullet. Now m of the mass is going to be 4m, and your v of the mass is going to be at rest initially, so it's 0. Your initial is equal to mu. Then after the collision, you're going to have one mass. That's your m plus 4m equal to 5m. And your VF is going to be equal to a V. So your final is equal to 5m times V. If you set them equal to each other, you get mu is equal to 5mv. You can quickly cancel out that m. You're going to get u is equal to 5v. So that's going to be D. Now two skaters, they're going to push off each other on frictionless ice. One has a mass of 2m and moves to the left at speed v. What is the speed of the m skater? So we know that they start at rest. Because we said they're pushing off. So before they pushed off, they start at rest. If they start at rest, that means that the initial momentum is equal to 0. So if the initial is equal to 0, your final also has to be equal to 0, because we have conservation of momentum. So now we can write the momenta. Let's make the right side be positive. So we know that for P1, our 2m skater is going to move left. So if it's going left, we're going to say negative v. That's going to be negative 2mv. Now for P2, it's going to be a mass of m, and it's going to move with speed of u. This is going to be mu. Now we can set our total momentum equal to 0. So our initial is equal to our final. We can set this equal to 0, negative 2mv plus mu. This is equal to mu is equal to 2mv. U is equal to 2v. So our answer is 2v.